Hey guys, so today we're going to be talking about congruent triangles and how two different triangles can be the same or equal to each other. So in our definition of congruent polygons, right up here, it says that two polygons are congruent if and only if their corresponding parts are congruent. Okay, a corresponding part is just a part that matches on two different shapes. So you'll see right here, angle B has one line, and angle J also has one line. So these would be corresponding parts, and you'll see also that they're both colored blue. Okay, so these two angles would be congruent. Okay, so where AC, green to blue, has 3 lines, 1, 2, 3, HK also has 3 lines. So these are corresponding parts, and they are congruent. So an example of corresponding angles, these are actually color-coded by the picture. So angle A and H are both congruent, they're both red, and they have 2 lines, okay? B and J, and then C and K. C and K both have 3 lines, all right? They're both that exterior part, okay? Corresponding sides are where you go from point to point, so you're always going to have 2 points to make that line. So AB, you go from 2 lines to 1 line, is the same as HJ. 2 lines to 1 line, or on this case, color-coded, HJ. Okay, you do that with each of the corresponding sides, and that's how they determine congruence as far as the sides go. So our angles have arcs, and then our corresponding sides have congruent tick marks, these straight lines. Okay, a congruent statement is just saying that this specific shape, in this case this triangle, A, B, C, red, blue, green, is congruent to the other triangle, HJK, red, blue, green. Okay, so we're going to do a practice problem like that and determine those matching angles, corresponding sides. Okay, so example 1, identify corresponding congruent parts. Right, it says show the polygons are congruent by identifying all the congruent corresponding parts, right? Basically all the parts that match. Then write a congruent statement. Okay, remember this is your congruent statement. Okay, so I personally like to start alphabetical order. Okay, sometimes your arcs will be singular, sometimes they're not, right? But personally, I just like looking at the alphabet first if I can. So we have angle P, which has 1 line. So angle P is congruent to, look for the matching corresponding angle, which has 1 line, or G. Angle P is congruent to angle G. Okay, then we're going to go to the next one. Again, I like alphabetical order. This goes to 2 arcs, so angle Q is congruent to angle F. Right? Again, we're matching up those arcs. Okay. Next one, angle R is congruent to angle E. Right, and then last one, angle S. 1, 2, 3, 4. We'll do a different color that's not green because we already used green. 1, 2, 3, 4. So angle S is congruent to angle D. Right? As far as getting our corresponding sides together, I'm just going to do those in black. So I like to start, here we have 1 tick mark, and here we have 1 tick mark. So going from one point to the next, I started my angles with P, so I'm going to start my side with P. So we have P to Q. So side PQ is congruent to, again, you started with your green angle, find the starting point on your other one. So we start with G, GF. Okay, then we're just going to continue going in that order. We stopped with Q. Okay, so now we go QR. So side QR is congruent to FE. Okay, now continue that path. RS. So side RS is congruent to ED. And if you notice, both of these sides have 3 lines on them, so they are congruent. ED. And then last one, SP, we're back to where we started, is congruent to DG. Okay, so we found our corresponding angles and now our congruent corresponding sides. Last thing we have to do is write a congruent statement. Okay, so in this case, we don't have a triangle, we have a polygon. So I'm going to say polygon and then start with my first angle I wrote down. So P, and then just go in order. Q, P, Q, R, S, okay, is congruent to, and remember when you're writing these down in order, they have to match up. So P, remember, was corresponding with G, and then we went F, E, D. Okay, so polygon PQRS is congruent to GFED. All right, on our next example, we're going to be using the corresponding parts to find missing angles or missing values. All right, so I know triangle ABC, so ABC is congruent to DFE. All right, it tells me right here. Find the values of X and Y. So now I want to figure out what I need to solve for. Okay, so I have 8y minus 5 here, which is this angle. Okay, I know by my congruent statement, this pink angle is congruent to F and B are corresponding. So this angle, 8y minus 5, is going to be equal to 99. Additionally, I know that my side FE corresponds with side BC. So 2y plus x is going to equal 38.4. Now I just have to set up my equations, right? So it's easier to solve for one variable at a time, okay? So I'm going to start with this one first because I don't know what either of y or x are yet. So I need to get one solved for before I can solve for the other. So just like we said earlier, angle F, which is 8y minus 5, corresponds or is equal to 99. Okay, corresponding angles are congruent. Okay, so since we know that these are congruent, we're just going to set them equal to each other and solve for y. Okay, we get 8y equals 104. Divide both sides by 8, and then we get 13. Okay, now I know my value of y. I can solve for x. Okay, we said earlier that side FE, or 2y plus x, is equal to, or congruent to, 38.4. All right, we just determined that y is 13, so we substitute that in, and then we're going to get the rest of the equation. Okay, so 2 times 13 is 26. We're solving for x. 4. Okay, when we subtract 26 from both sides, we are left with x equaling 12.4. Okay, 2 more examples. All right, so this is congruent triangles continued. So we had 2 theorems we learned yesterday. Here is a third theorem that we're going to learn. This is called the third angles theorem. Okay, so if 2 angles of one triangle are congruent to 2 angles of a second triangle, then the third angles of the triangles are congruent. Okay, what this is saying, so if C is congruent to K, okay, the red angles are equal, C and K, and B and J are also congruent, then A and L, we'll color these green, also are congruent. Okay, keeping that in mind, we're going to keep going to the next example. All right, so use the third angles theorem. So the planners of the senior banquet decided to fold the dinner napkins using the triangle pocket fold. Okay, so they can place a small gift in the pocket. So if angle NPQ, okay, NPQ is congruent to RST, so these 2 angles right here, and the measure of NPQ is 40, right, so this angle is 40. All right, find the measure of, we'll do this green, measure of SRT. Okay, so we need to find this one. Okay, so let's take this angle picture apart. Okay, so I have NPQ. Okay, we know P is 40. Okay, and then we also have, let's make that prettier, SRT. Okay, so both of these are right triangles. All right, sometimes it's easier to visualize two separate triangles than it is to picture what's going on in the middle. So we know that NPQ is 40 degrees. We want to find SRT, or this green angle right here, SRT. Okay, so what do I know about this first triangle? Okay, so I have NPQ. This is a right triangle, so this is 90 degrees. Angle P is 40 degrees, which means N, according to our third angles theorem from yesterday, remember they have to equal a total of 180. Angle N is going to be 50 degrees. Okay, so how I did that, remember a triangle has 180 degrees total. Okay, so Q is 90 degrees, and then P is 40 degrees. When we add these together, we get 130. Okay, so our leftover angle N, has to be 50 because 130 and 50 equals 180. So if we know angle N is 50, looking at SRT, R also has to be 50, okay? Because remember, T corresponds with Q, P corresponds with S, so P and S would both be 40, okay, which makes, by our third angles theorem, R equal 50 degrees. So the measure of angle SRT equals 50 degrees. All right, and then the last one, we have an example. We're going to be writing a proof, okay? So write a two-column proof. We're given that side DE is congruent to GE, okay? So DE and GE, and then we're also given DF is congruent to GF, and angle D is congruent to angle G. DFE is congruent to GFE. Okay, so all of these little instances are marked with these little ticks and arcs. Okay, we need to prove that triangle DEF is congruent to GEF. All right, so first step, we're going to write down what we know. Okay, so we know that DE is congruent to GE, and DF is congruent to GF. Okay, and the reason for this is because it's given, all right? Remember, anytime you're given information, you just write that down. Okay, number two, we know that EF right here is congruent to EF, all right? And where that comes from, that is just the reflexive property of congruence. Okay, and what that means, so EF for this triangle is going to be congruent to EF on this triangle. Okay, because they share that side. Right? Third one, angle D is congruent to angle G, and DFE is congruent to GFE, and again, this was given to us. So we're just piecing all of this together to show our proof. All right. Next, we're going to say DEF. So DEF, this angle, is congruent to GEF, right, by our third angles theorem. Okay, because remember, we just learned that when two angles in a triangle are congruent to two angles in another triangle, the third angles are also congruent. Okay, so this is our third angles theorem. And then last but not least, triangle DEF is congruent to triangle GEF because that's your definition of congruent polygons. Okay, so DEF is congruent to GEF. Good job today, guys.